All right, y'all. How's everyone doing? I am back with a repair video. This is another work-related video, not a personal project. I've just been very busy with work, and a lot of it is due to some of these projects I've shared with you. And these aren't run-of-the-mill projects that I deal with. They're a bit more unique, and in that some of them are repairs that I'm trying to perform for the first time, and they're also repairs that there's very limited resources on how to do if you're in a position like me. They're also probably repairs that the manufacturer isn't doing either, and this definitely goes for this one that I'm about to show you. But that's why I want to share it with you guys. Could save you a ton of money in your lab. And yeah, so let's get started. So what I'm going to talk to you guys about today is a specific type of centrifuge, and I'll show you guys that centrifuge in a second. But it's the Thermo, so ThermoFisher Sorvall XTR benchtop centrifuge. These are a pretty large benchtop centrifuge. Depending on the rotor, I'm not exactly sure what the max rotor speed is, but for us we use swing bucket type rotors, and they can get up to 4,000 RPM. So we'll use them to spin microplates and larger conical vials, like 15 to 50 ml conical vials. They are a workhorse in our lab. We have about a dozen of these centrifuges, but they aren't the newest model in this class that Thermo offers. They're discontinued. A lot of ours are now getting to be about 10, 15 years old, so they are starting to have some issues, like one I'm about to show you here. But anyway, that's the make and model that we're going to be working on today, and the fault, or the issue. So an end user came to me and stated that they tried to use the centrifuge, but the display, which I can show you what that looks like. So I have one of these here. The display, LCD display, or LED, it's LCD, it's a liquid crystal display. It was just blank when they tried to power it on. The buttons wouldn't respond. It was just the backlight was lit, and that was it. So power was getting to this, but nothing was responding. And so, I said, all right, I'll take a look at it. And what I did first was try to see if it was the display itself. And so, like I said, we have a ton of these. I just took one of these from a working one, put it on, same exact symptom. So it was clear that it likely wasn't the display that was the problem. That meant it had to have been on the main board, which I have right here. But it didn't seem to be a power supply issue. Like I said, the liquid crystal display was getting power, and I checked the power rails and everything checked out. So started looking at the microcontroller, which is right there. It is an Infineon series microcontroller. It's an SAF-XC164CS, 125 kilobytes flash memory. These also have a NVRAM chip as well, which at first kind of threw me off. I thought, well, maybe this is a ROM-less chip, but it's just non-volatile RAM. So, if you're looking at these and thinking, well, all the programming is in that chip, that is incorrect. That is just basically saving some of the data that, like the how many cycles this thing has ran, probably programs that the end user can create, that'll set the RPMs, and so they can just pull it up real quick. That's where that chip stores, and that also was fine. So I started looking at the microcontroller. All right, and you know, it was doing some, you know, checking around with the oscilloscope, and it definitely seemed like there might be an issue there. So I decided to order a replacement, and I figured I'm going to try to flash this chip. We have, like I said, we have plenty of these that are working. If it's not read protected, should work out fine, right? So that was my plan, and that's what I'm going to show you guys how to do. It turns out these aren't read protected, which is a little surprising, but at the same time, it's a centrifuge. You know, it's not something that is really proprietary or hard to replicate. You know, it just needs to track the speed of the rotor, work the lid lock. You know, there's not too much going on there. So, you know, but still, it's so easy to protect these with these days. So it was, but anyway, yeah, they're not protected. So you can flash them, and that's what I'm going to show you how to do. All right, so I figured you're going to need some tools or some materials. Infineon, in my opinion, I haven't flashed that many chips. I've done an STM chip, which there's a ton of resources for how to do those. I never did an Infineon before, and it was a little bit difficult to find the resources that you need. Also, this is a chip that's at its end of life. All right, it's discontinued practically. I think you can still get them on Mouser, but I'd imagine that they're not going to be around much longer. So if you do have a ton of these and you want to try to perform this, or you think you can, I would go and grab these just to have on hand so that you can do this and save yourself a ton of money. Because this board, brand new from the manufacturer, is $3,300. It's the most expensive part in the centrifuge. All right, so just, you know, but anyway, all right, so the setup. Basically, when it comes to flashing chips, you've got to get them into a mode where you can program them, and that isn't the normal operation mode. It's usually putting them in the bootstrap loader mode, or BSL. And so that's what all of this is here, okay? Again, some chips, it's easier to do that with. Others, it's a little bit more complex. But there are 4 pins of interest that you need to be concerned with. Those are, on this chip in particular, it's pins 63 through 66. So that's these here. The address, latch enable, external read strobe, external write, EA, and then of course there's the reset output pin as well. Those are just all in the port 20 pins. We're more concerned about the first 4. And so those are pins, like I said, 63 through 66, and you're going to need a way to connect to those, and the best way that I could come up with was attaching some 0 ohm resistors. There's 4 vias right there. I know it's kind of hard to see because there's all that flux residue, and actually one of my 0 ohm resistors popped off because there's very little area to solder them to, but this works just to perform this task. So you can connect them there. You don't necessarily need a 0 ohm resistor, but you know, an old lead from a component that you're not using will do fine. Just something to connect your leads to. And you're going to need a way to tie these pins to either high or low, depending on what configuration you need, and that is what I've got going on here. Now, another resource that I used to do this because I'll tell you, the user manual and the data sheet, they're a little bit difficult to follow for putting this thing in a BLS mode. It can be a little bit confusing, especially if you've never done something like this before. So I found an application note that was very helpful to me. Let's see, I'm going to link all this into the description of the video, by the way. It's basically this application note, XC164CS series EasyKit. And so there are these kits, these development boards that I don't know if they're still available through Infineon, but basically they're just development boards that you can use to program these chips, and they are not necessary for what we're about to do here. You can definitely just do it in circuit like I'm about to show you, but there was a lot of information here that was super helpful. All right, and one of those things was providing the materials that you need to do this. So here's some configurations, again using those 4 ports. All right, so it gives you some of the startup configurations. This is the one we're interested in, the bootstrap loader via ASCO0. Okay, and yeah, and then again here now what they did is, so you could switch between these modes, is on this development board there is a series of dip switches that you can use to put the chip in a variety of different configurations, and that's basically what I built here. Now, I didn't have any dip switches, so I just used jumper wires that I would connect or disconnect based on what configuration I needed. Then there's just some resistors as well. I'm going to show you guys what I used for this as a resource. This is the schematic for this EasyKit board, and this is what I was interested in. This is the dip switches here. Okay, this is the port 20 pins I was telling you about, 63 through 66, and you can see they've got some resistors, 5.6K resistors that are then tied to ground. One of them is tied to the 5 volts, the VCC. So I just copied that onto a breadboard, and that is what I would suggest you guys do. I don't know how necessary the resistors are. You could probably just tie them directly to ground, but I didn't want to damage anything, so I just figured I'd copy this. I would suggest you do the same unless you have more experience or know why they may not be necessary, but that's what I did. Also, a couple other things that I did was I wanted a way to reset the board without necessarily having to power cycle it with this switch. So I added a switch there, which again is just copying this schematic. This is the reset pin, and you can see if you follow that down, it is then connected to this reset switch, which is then tied to ground, because you're just pulling that low to reset it. And so that's all that is going on there. Also, I'm bringing ground over. I mean, you could do that a number of different ways, but this X13 connector has some ground pins associated with it. You can also pull the reset pin from that connector, and I can show you guys where I used that for a reference. So you can actually find the schematic for this series of centrifuges. This is not exactly for the XTR, but there are a lot of centrifuges like it where almost everything is practically the same, and that is true for the microcontroller. So I can link that in the description as well. But if you look here, this is the X13 connector that I was talking about, and you can see 2 is VCC, 4 is ground, and then 8 is the reset pin, number 1. All right, so you can just pull jumpers from that, like I've got here. Okay, so the red one is 2, the green is 4, and then the other green is 8. You can pull those and you can put them onto your breadboard. All right, so that is basically what you would need for the startup configuration to put this into bootstrap loader mode. All right, now after you've done that, you're going to need a way to interface with the chip with some software, and a way to connect the transmit and receiver pins of this chip to your PC. And the way to do that, one of the ways I've used in the past to do that, is using a UART to USB cable. Now this is an FTDI. I'll link the also the which one this is, but actually I think I have. I can pull that up, the data sheet for that as well. All right, so this is this cable that I was telling you guys about, this USB to UART cable. All right, and again, for setting this up, the application note that I showed you was extremely helpful. So this is the diagram of the all the pins, and it's all color coded, so you're most interested in these orange and yellow, which is transmit and receive. Okay, so these are going to need to connect to, again, the transmit and receiver pins on your the micro. All right, and again, you can follow the schematic to access these, but basically you can access these right here at this X14 edge connector. All right, so 2 is the transmission, and 3, if 1 is over here, 4 is over here. Zoom in a little bit closer. Okay, so you see 1 right there. So again, 2 is transmit and 3 is receive. You're going to need to connect the receiver pin to the UART to USB that connects to your transmission, and then same here, transmission connects to the receiver. All right, so that is coming from the UART cable to USB. Another thing, you're going to need to tie this cable to ground, and that's done from the black cable here. So I've got that tied to ground there. And then one last thing you're going to need to do is you're going to need to tie these, short these together, green and brown, which are RTS and CTS. You're going to need to short those. And again, for reference, if you want to check that out, this is what you're going to be using as a reference. So again, 7 and 8, that's basically RTS and CTS. So there you go. And see, that's for the ASCO. That's the bootstrap loader we're interested in. All right, so that is basically the setup. And next, what I'm going to like to do is get into how the software works, how you can set that up so that you can interface with this micro and then flash it. So let's do that next. All right, so this is the software that you're going to use to interface with this MCU. It's called MemTool 2021. You can download this on the Infineon website. I can also put a link in the description for this too. But yeah, it's relatively straightforward to use in some respects. I mean, if you look at it, it looks pretty simple. But what you're going to want to do is you're going to have to get some information on the target. All right, so first thing you're going to do is in this area here, you're going to go to change. Now you can see here, I've already got the target. This is what you're going to want. EasyKit with XC164CS, but let's say if we wanted to create a new one, right? So you have the option of creating a new target from scratch or using a default configuration. Now, you're going to just use the default, all right? So the XC164CS is within the XC16X series. So we're going to open that up, EasyKit's bootstrap loader, and then you're going to scroll down to your MCU of interest, which is, in our case, this EasyKit with XC164CS-16F. That's the XTR micro. So you're going to click that, and you're going to click Finish. All right, and then it'll save it for you. You're going to click Save, and then that'll be that. But since we already have it, I'm not going to go through that. Now there is some things that you do want to edit in this. Just one thing. All right, so you're going to just see. Yeah, so here, I might have went through that a bit quickly, but let me just try that again. Let's go to Edit. I think I just double clicked on it. Yeah, all right, so you just double click on that. This is what you're going to want to change. The external clock frequency as a default is set to 8,000 kilohertz or 8 megahertz. So on the XTR mainboard, it's 10. So you're going to switch that. Again, I don't know how important that is, but I would just do that. And that's really all that you're going to need to adjust. So you can, once you do that, you can click OK. But since we've already done it, we're going to click Cancel. So that is what you're going to need to set up. The next thing you're going to need to set up is how you connect, how you're interfacing with it. So you're going to go to Setup. And then based on what you have available, it's going to, for example, if you've got the same UART to USB, it's going to pop up here as a USB serial port, and then based on what COM port you're in, that'll show up there. In our case, it's COM 3. All right, so that'll pop up. This is the important part, though, okay? The command lines for the RTS DTR handling, that is not populated. You'll need to populate that yourself. And if it wasn't for a short tutorial on YouTube on how to use this software, I would not have known how to do this. I can also link that in there as well, but basically the information that I was interested in grabbing from that is the commands for the RTS DTR handling. So this is them. It's the first one is set RTS, and you're just going to use this button here to write new commands, and then you just keep clicking that, and you can keep adding them, but it starts with set RTS, set DTR, wait 100, clear DTR, wait 100. That's it. For disconnect, it's clear RTS, set DTR, wait 100, and clear DTR. All right, so you're going to need to populate these as well. Yeah, there are some other things that you should be aware of, like the baud rate. I believe its default is 9600. You don't really need to mess around with that. That's what I have it at. It's fine, so it works fine, so you don't really need to play with those settings, okay? But yeah, so here it is. Yeah, that works fine as well. But that's really that is a key piece of info that added knob, again, because there is no user manual for this MemTool software. I found a tutorial, but it's doesn't cover everything, and I think it's because maybe it's so outdated that there was a manual at some point, but it's no longer available. I'm not sure, but I struggled to find one where it might have kept some of this information handy. But yeah, so once you set this up as well, you can just click OK, and then you're pretty much ready to connect with this, with the micro. And I'm just going to show you guys that now. Now I've already flashed the chip that I showed you on the main board. That's the new one. It's already been flashed successfully. So unfortunately, I'm not going to go through all of that, but I'll kind of walk you through what you need to do through the software on how you can do this. Now, what I will show you just briefly is an example of how connecting to the how a successful connection would look. All right, so I'm going to power this guy on. And then we're going to click connect, and all should go well. Let's see if I did this correctly. Yeah, so there you go. That's just like that. You can see now it says ready for MemTool command, okay? So that is a successful connection. Now, what you're going to want to do is you're going to want to read the chip. Now, you're going to need an existing XTR, a known working XTR. If your main board has failed and there's a big hole in the center of your micro, you're not going to be able to do this. I have in the past flashed microcontrollers where maybe just one or two I/O pins were bad. So it is possible to do it with a faulty one, but if it's a total failure of the chip, you're not going to be able to do this. You're going to need a working micro. Now, what I can do is I've also started an EEV blog thread on this, where this video will be up there, and in that thread, which I can link in the description, you can have access to the hex file. So in the event you don't have a working XTR to do this, you only have one, you won't need to do this. But let's say you do want to go through the whole process, you're going to need to click read, and you're going to want to set up a list of sections to read. Now, this is already broken up in how the sectors for the memory, the flash memory, this is how you're going to set this up. All right, so for example, I can show you just adding a new one. We don't need to because it's already here, but this is how you would do it. So you're going to click new, and then this is how you add a new section. So start address, end address, it's already all there for you right here. And then the section size, well, for example, if we did the first one, it would then go to sorry, I'm bringing the thing out of focus, but in section size here, it would then, for example, again, if we did the first one, it would automatically populate as 8K, okay? And then you click OK, then you would keep adding the other ones, all right? So that's how you would specify a list of sections to read. If you don't do this correctly, you're not going to be able to, when you go to try to program it, it's not going to work. You're only interested in bringing the flash memory over. All right, so that is, and unfortunately, since the target configuration is already is one of the defaults, this is populated automatically. And yeah, so it's pretty straightforward once you get the hang of it. I'm just going to click cancel here, and then I'll show you. We'll just do a read right now. So I'm going to click start, and now it's reading the chip. Yeah, so I mean, it's pretty straightforward. It's pretty easy to do, and what I'm hoping is, especially with this video, you guys will have, it'll be a breeze. And yeah, so when it's done, it'll say success. You can click exit, and then that read information is now right here. What you can do is then click save as, and you can save this as a hex file, and you'll be good to go. And then what you would do is you'll take that, click, when it's time to connect to the new micro, click open file, pull that hex file, click open, select all right, that'll bring that over here. Then you'll click program, and that'll be that. I mean, when you're done with the programming, what you're going to want to do is you're going to want to disconnect it, all right? And then we'll go back to that application note I was showing you guys, because that'll walk you through basically how to do that. So you want to make sure that the program is successful. All right, so again, it's walking you through how to do some of this. It kind of goes through some of what I showed you here a bit. And yeah, so after successful programming, you're going to disconnect. All right. Oh, sorry. I guess maybe I already disconnected it. Oh no, I think I opened this twice by accident. All right, so yeah, let's say we just programmed it. We're just going to click disconnect. And from there, you're going to want to bring your chip back into standard mode. All right. So whether you have a dip switch that you want to put on your breadboard, or you're using jumper wires, you're going to put it back into this mode, reset it, and it should be programmed successfully. That should be it. And you'll be good to go. Now, I do want to go over a couple other things with you guys real quick, and then we'll wrap up. But I hope that was pretty straightforward. Okay, so now I'm just going to show you guys how this thing should look after you've done a successful flash of the chip. And yeah, I just wanted to give you an example of that. So now I've just connected the display and the buttons to the main board, and I'll just power this guy up. Now this is what I meant by just a blank screen. So that would never pop up. Now it's gonna be unhappy because all of the motor, all of the inputs basically have been disconnected. So it's not happy right now, so it's definitely going to throw an error, but this is a good indication that you flashed the chip successfully. And now after that, it's time to connect everything, put the board back into the centrifuge, connect everything, and test it. See if it powers up without any errors. Now, I do want to go over a couple of other things real quick. All right, so there was a bit of a plot twist here. So when I did the flash for this board, I did exactly what I showed you guys here, and this was still blank. And so I thought the flash was unsuccessful. I thought maybe this chip is read protected, and that, you know, it really kind of threw me for a loop. But what I found is this D43 was faulty. This is a 74 HCT138. It's a 3 to 8 line decoder, and removing it allowed this thing to power up and boot up just like I showed you. Now that is an interesting, it's interesting to me that little IC, which to me seems like it's just involved with the display, disabled the entire boot up of the MCU. And people smarter than me, if you can give me some indications why that happened, but I'll just show you guys in the just the schematic. So again, these are the 4 pins that you're interested in. All right, there's a 63 through 66, and so those, if you follow those on the service manual, let's see. Okay, yeah. So if you look here they are. All right. Well, that's the reset. That's pin 2, I believe, but no, I'm sorry. Anyway, this is pins 63, 64, and 65. They connect. They are the the inputs to this chip, and then you have the outputs, which then move on to X19, which is the connecting cable to the overlay, which is just this part right here. So for all of the buttons, okay? For some reason, this chip being faulty caused this whole MCU not to boot properly. And again, I'm really curious as to why that is. So if we just go back, so here, yeah, 63, 64, and 65. That's them right here. I don't know if it's because these pins also, as we've showed you, they play a role in the startup configuration, but you know, if this is programmed, these pins can just be used as general input, bidirectional input-output pins. So yeah, it's just a very interesting fault. Yeah, so let me so anyway, in short, replacing that decoder fixed my problem. In fact, this whole time, that original MCU might have been fine. But it was still good to go through this, because now I know that I can flash these successfully if there's another catastrophic failure of this board. So it was still good to go through that process, and I can also share it with you guys as well. So if you do have a similar issue, unless it's readily apparent that this, you know, like I said, if there's a big hole right through the middle of that, your MCU, if it's something a little bit more subtle, like what I was dealing with, I would recommend just removing that decoder from the board and see if it powers up then. If it does, your issue is not with the MCU, it's with this chip, which is just a, you know, they're like 50 cents a piece. You can get them from Mauser, and then replacing that should fix your problem. But still good to know how to do this. Another thing that I've seen that's more common, this is my first time having an issue with on the digital side of one of these boards, but I have had a couple instances that are more so related to the power supply. And the main weak point, I think, of these, see if I can zoom in, is that V21 SOT23 right there. That is a Zener, I think it's like a 24 volt Zener diode. I've seen those just thermally degrade and cause problems for the power supply of these. Okay, watch out for those if you're having some other issues. If, for example, you're having hiccuping that occurs, I've seen that happen. Definitely look at that. I've also seen some other errors which are starting to I can't think of off the top of my head, but caused by that SOT23 going bad. So that is more common as far as issues with the main board, but even an even easier fix. Again, that's a very cheap component, very easy to replace. So watch out for those. But what I'm going to do is I'm going to put this thing back together. Just show you guys the finished unit in working condition. There are a couple other things I'll show you guys that are main issues that can occur with these that could be potentially expensive to fix if you go through the manufacturer, or you know, you follow their advice. I can show you guys much easier and cheaper ways to fix them. Alright, so it worked. Everything is connected, and you know, I still need to tighten a few things in the back, and of course reconnect the boot, and then I'll power it up and do a actual test run. But this is a great sign. There's no errors. Everything on the front panel responds. These buttons, this is again my camera, they aren't flickering like this. That's just the shutter speed of the camera having that weird effect. But yeah, everything looks great. Now, I made a really silly mistake, which I'm going to show you guys to be careful when you're taking these apart. So I actually borrowed this front panel from a different XTR. Man, it really pained me after all this work to do that. And unfortunately, that's going to mean it's going to be a little bit longer till this one will be up and running for my end users. But oh man, that really killed me. But anyway, while I have this open, I'm going to show you the other stuff on a different unit. Some of the things to look out for when you're putting this back on. Be careful. This imbalance sensor, okay, it's the rotor boot, this rubber part, it needs to be on the bottom, like you can see here. Sometimes it's easy if you're replacing this, for example, or just taking this off. Sometimes this piece will get exposed, all right, and then that will be sitting on the bottom. Okay, you can't let that happen, because when you try to put this back on, this boot can just spin around, and then what'll end up happening is it'll end up tearing this guy out, because this sits snugly in here. So if this starts spinning around the rotor motor due to the vibration of the rotor or whatever else, you'll rip this out. I've seen that happen with these, so just be careful when you're installing this, okay? Just a quick trick. But yeah, let's take a look at some of the other things I was mentioning. Alright, so we're at a different XTR centrifuge. I just wanted to show you guys a couple things, and by the way, you can just see how big these guys are. They're hard to move around. They're not easy to work on for that reason, especially when you've got to pull the main board out. Generally, like for example in our lab, you've got to turn this whole thing around just to get back there. But yeah, so anyway, I did want to show you guys the lid lock devices. So these are what lock the cover lid, all right, and then when when these come down, once these come down, there is a micro switch that senses when they're down, and that will engage the motor to rotate these forward to pull the lock, pull the lid down even further and lock it in place. And so, like I said, I mentioned a micro switch. There's actually, I think, 4 micro switches in one of these devices. So again, they're just basically providing information to the main board about the state that the lid is in, and the lid lock itself to get the motor to engage. There's also a micro switch in the back of these that will tell the centrifuge whether or not it's in a emergency release state. There are, let me see if you guys can see it from here. Yeah, there is a cord on each of these that goes all the way to the back, so that way if you lose power while this thing is still on and it's locked, you can emergency release it. Alright, so these, generally there's not much that goes wrong with them. I mean, on an annual basis for a PM, I will clean them of dust and then re-lubricate them. But one thing that does go bad on these, and I've seen it happen multiple times, is on one of the switches, let me get my flashlight for you. That one right there, you can see those black and blue leads popping out at the back. That switch is problematic, and the reason for that is those leads there, when this motor is moving, this whole apparatus kind of moves when the motor moves. And in fact, I'll show you guys that in a sec. Actually, it's out. The thing is off now, but I'll try to show you guys that. But anyway, when this thing moves, those two leads, they come in contact with a bar on this. That's an internal part. They come in contact with a bar, and those leads will brush up against that bar, and over years of that happening, they'll eventually get brittle, and then they'll break, and they break literally at the switch. There's no way to reconnect them securely, so your only option really is to either replace this whole apparatus, which is what ThermoFisher will tell you to do, and they are roughly $1,200 new, or you can replace the micro switch, which is what I do. Now, it's funny, and again, you hear me talk a lot about repair prevention strategies. ThermoFisher will tell you that if you take this thing apart, you essentially break it. You can't put it back together. If you try, it will not work. That is a complete lie. Okay? You can take these apart. It is a little bit of a pain. You can see that there's all these springs in here. They're like a bear trap, sort of, to try and, you know, put back together and take apart. It is a pain. I will admit that, but it's possible to do. And especially you have one to use for reference, but it's certainly not impossible. Sourcing the switches, you know, tons of companies make these micro switches, but the actual manufacturer for these is a company called Zippy, based in Japan. And years ago, I just bought like 50 of them for, I don't know, like 80 bucks, including shipping. And I figured that would last me a pretty long time. I mean, $1,200 versus a couple dollars for a switch, I definitely recommend going that route. And if I ever have another one of these break, you know, if you guys would like, I can do a video on replacing that switch. But that's really one of the more one of the faults that will cripple one of these and could potentially cost you a lot of money. It's an issue like that, or the main board. Those are really the two main parts that can cost, you know, a lot of money. Now, obviously, there are other components in these that can go bad, like the motor, and these are refrigerated, so there's a compressor as well. You can have issues with the refrigeration system potentially, but I haven't seen any issues like that so far. And like I said, we have a dozen of these. They are, you can see this one's from 2012, so it's a little over 10 years old. All of ours are anywhere from 10 to 15 years old. And so main board issues, these lid locks are really the two main things that I've seen. Now, another thing while I'm here is to do a repair on the main board and a few other repairs, you've got to remove this AutoLock. So this device is what locks the rotor in place. Okay, that's the type of rotor we use, the swing bucket rotor. And you do need a couple special tools to remove one of these. Now, you can see these two torque pins. So these auto locks aren't on here too tight. I think the spec from the factory is 5 Newton meters, which is roughly 50 inch-pounds, so it's not that much. But these do get, you know, a little nasty over time. They can take on some corrosion or rust, and they can be a little bit difficult to get off sometimes. So it helps to have a way other than just holding it to keep it in place. Now, Thermo makes this special tool for that. The problem is they don't sell it separately. You need to buy it in this kit that literally costs almost $1,000. Really, the only thing in this kit that I think is any value is this tool to hold this in place. But I came up with my own tool. It's using something like this, a thick ruler that I can hold over the over the torque pins like this, and then I can put a 3mm Allen key in the hex screw to unlock it, untighten it. Now, to get this off, you're going to need to loosen it, do 4 counterclockwise turns with your Allen key, and then you need to get one of these cone pullers, and then that is how you'll be able to remove it the rest of the way, and then you need to just come back with the Allen key and you'll get it off. That's the only way you can get it off. You can't just use an Allen key to remove this, so you're going to need one of these. Now, you can get these anywhere, but if you want one that is pretty much, I wouldn't say it was made specifically for these, but there's a company called Ozark Biomedical that sells these, and you can get this exact one from them. But again, you can probably get one of these anywhere. If you want, I can do some measurements for you to figure out what size it is, but yeah. So yeah, that's how you'd remove it. And of course, like I said, watch when you're putting the boot back on. You know, you've got to be careful there. You don't want this spinning around the rotor. But yeah, that's one of the big things. One of the only tricky parts of servicing these. I mean, I guess I shouldn't say that. It can get difficult to gain access to them. If you ever had to remove a motor from one of these, it could probably prove a little bit difficult. I haven't had to do anything like that yet, but you know, we'll see. When that happens, I can do a video on that if when the time comes. But that's really all that I wanted to share about these. I'm going to finish up that one over there, do that test run, and that will... Oh, this is what I was referring to, that big mistake I made. So this is a for the RS-45 connector. Basically, what can happen is when you're working on one of these and you have that for the display, this is for the display, okay, and when it's secured to the big panel in the front, it can be very easy to drop it. You really got to be careful there. And it slipped out of my hand, and it was still connected to the RS-45 connector, and it literally pulled it out, and it damaged some of the pins, and so I'm gonna have to replace this connector. I mean, these are really cheap. It's just unfortunate that my the end users are gonna have to wait a little bit longer while I get that part. And so just be careful when you're working on that. It's a very easy mistake to make. But yeah, I think that about wraps it up. I'm just gonna run that test, and then just some closing remarks, and then that'll be it. Okay, so this is what I was referring to about the lid locks moving. I can't, I know, but you can just, I hope you can make out that switch moving. See how it, and then it comes in contact with that bar below it. It's actually below it. That's, yup. And over time, those leads will hit that that bar, and then they'll just break off. So just be careful for that. Okay, well, that looks like a wrap on these XTRs. So I did manage to do a quick run with the one that I just repaired, borrowing this front panel and its display, and it did just fine. I ran it at 2,000 RPM for about a minute, and everything worked great. So that one, as soon as I get in that RS-45 connector, that'll be good to go. Once I replace that faulty one that I... Oh man, I'm gonna be kicking myself for that one. But look, that happens, you know, mistakes happen. Just be honest with you know, whoever you're serving, in my case, my colleagues, and yeah, they'll understand, you know. So, but yeah, I hope you guys found this interesting. You know, I hope if you guys do have these instruments and you do run into this problem, you can use this video as a resource and potentially save yourself a ton of money. I mean, look, obviously to do this kind of work, it does require some upfront tools. It does require some skills. You know, you need to learn. You need to know how to solder. You need to know how to solder well, because that micro is a 100-pin SMD chip. So you know, it does take some skill, but all that stuff you can learn. You know, and there are other videos on YouTube, for example, where they do great tutorials on soldering. So things like that you can pick up as well. But, you know, again, this has the potential to save you a ton of money in the long run. And if there's anything else you guys want me to do related to centrifuges like this or any other lab equipment you might be struggling with, I can just put it in the comments. I'll see if we have that equipment here, if there's a video I can put together on it. And also hopefully I'll get back into the personal projects as well. But anyway, thanks for watching, and I'll catch you guys next time. All right.